Hello everyone, we are about to start our final lesson for our solutions unit. We are right here now. We are going to be answering this question. How can we quantify how concentrated a solution is? You will note that you will need table T today, and you need a calculator for this part. Today is May 12th, and the first thing we're going to talk about is the concept of molarity with a capital M. Molarity is the amount of solute in a given amount of solution. And as a reminder, a solution is made up of solute plus its solvent. And the equation given in table T is here. Molarity equals moles of solute per liter of solution. So here's some easy examples of molarity. A 2 molar solution has 2 moles of solute per 1 liter of solution. A 0.1 molar solution has 0.1 moles of solute per 1 liter of solution. It's really important to quantify molarity because that allows us to be more accurate as opposed to saying things like this is a concentrated solution versus a dilute solution. These are qualitative descriptions. We want to quantify, and in order to quantify concentration, molarity is the way to go. Okay, so let's look at a few examples here. What is the molarity of a solution containing 2 moles of potassium nitrate dissolved in 4 liters of solution? So we look at table T to see the molarity equation, and we plug in our numbers. Molarity equals 2.0 moles of potassium nitrate, but this has 4 liters of potassium nitrate solution. We divide and we end up with 0.5 molar KNO3. So it's an aqueous solution. Let's look at another example. What is the molarity of a solution containing 2 moles of hydrochloric acid dissolved in 250 milliliters of water? I'm going to underline that because it's important. So, molarity equals 2.0 moles of HCl, but it's per liter of solution. So we actually need to convert these milliliters to liters. And if you recall, there are 1,000 milliliters in 1 liter. So if we divide that by 1,000, we get 0.250 liters of solution. So you need to plug that in there. And we solve and get 8.0 molar HCl. And just to give a little look at these 2 examples, I have 0.5 molar potassium nitrate, and here's an 8 molar solution of hydrochloric acid. This is a lot more concentrated. This is a lot more dilute if we compared those 2 solutions. Our third example. What is the molarity of a solution containing 20 grams of sodium hydroxide dissolved in 2 liters of water? So now I'm going to underline here, grams. We need to convert grams to moles. We already have liters here, so we're just going to plug in that number there, but we need to make that conversion. And so I did this over here as a reminder when we calculate the gram formula mass. Each sodium atom has a mass of 23, oxygen 16, hydrogen 1. We add that up. We know that 40 grams of sodium hydroxide equals 1 mole of sodium hydroxide. Now, that's 1 mole is 40 grams, but we only have 20 grams. So let me just put this down here. 20 grams of NaOH. I wonder how many moles that is, because that's what I'm going to put into my equation. We know that 40 grams is always equal to 1 mole. So solving for X, and you can tell visually, I know, but solving for X, you have only a half a mole. So let's plug that in. Molarity equals 0.5 moles of sodium hydroxide. And that is in 2 liters of solution. And what do we get? 0.25 molar sodium hydroxide solution. Okay, so I want to talk to you a little bit about making molar solutions. Making molar solutions in the laboratory needs to be very precise and very accurate. There is a video that I'd like you to watch right after this one that demonstrates making a molar solution. And in preparation for that video, I'm giving the example that they use there. So in the video, they want to make 100 milliliters of a 1 molar sodium chloride solution. By definition, molarity, 1 molar solution has 1 mole of sodium chloride per 1 liter. And we know what 1 mole of sodium chloride's mass is. 23 plus 35 gives us 58 grams per mole. Now, I don't want to make a liter. I only want to make 100 milliliters. So we know, though, 58 grams would be in 1 mole, and a 1 molar solution would have 1,000 milliliters, the equivalent of a liter. We only want to make 1/10 of that amount. So how many grams per 100 milliliters would we need? Cross multiply, divide. We only need 5.8 grams of sodium chloride to make 100 milliliters of a 1 molar solution. And it's a really good demonstration in this video coming up. Okay, another way to measure the concentration of a solution is in parts per million. Now, this really only is used to quantify really tiny quantities of solute. And the word trace is used here. Trace amounts refers to very small or tiny quantities of something. And parts per million most often is associated with pollutants in the air or drinking water. There's very small amounts of solute per solvent. This is also found in Table T. In Table T, we see parts per million is the mass of solute per mass of solution times a million, parts per million. If I wanted to do parts per 100, mass of solute over mass of solution times 100. But this is parts per million. It is for very dilute solutions. So here's our example. What is the parts per million concentration of lead when 0.0000450 grams of lead is dissolved in 100 grams of water? So look at how small that amount is. So parts per million is important in this case. So we put that in the numerator. And notice that we're adding the solute and solvent together because this is the mass of solution. And we multiply by 1,000,000, and you're going to get 0.45 parts per million of lead in that water. Our final example, what would be the parts per million concentration of a solution containing 5 grams of solute dissolved in 250 grams of water? ppm equals 5.00 grams of solute and 255.0 grams of solution. Notice I've added the solute and solvent together to put in the mass of solution here. That's really important. Times 1,000,000. And we get 19607.8 parts per million. And if we want to be more accurate in our answer, according to the sig figs used here, our answer would actually be down to 3 sig figs, which aligns with the 3 sig figs used in this example. That concludes our lesson for today. I hope you enjoyed it. I hope you have a wonderful day. Bye.